Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss graphs. Friends, basic questions based on graphs are frequently coming in competitive examinations, right? And students, most of the time they find it difficult to attempt the question on graphs, right? So in this session we'll be discussing the basics of graphs and the basic graphs, and we will be discussing their applications as well. So let's begin this session. Now, first of all, we'll be discussing graphs of rational and irrational functions, right? The very first function is identity function, that is fx is equal to x. Now, friends, you must be knowing that there are four quadrants. Here, this is first, second, third, and fourth quadrant, right? In the first quadrant, x and y, both of them are positive. X and y, both of them are positive. In the second quadrant, x is negative but y is positive. In the third quadrant, both of them are negative, and in the fourth quadrant, x is positive but y is negative, right? So that you must be knowing, right? Here fx, that means it is a function of x, or we can call it as it as y, right? So here it is the graph of y is equal to x, okay? Now these are called coordinate axes. This is y-axis and this is x-axis, right? Here you can see the values of x are positive over here, 1, 2, 3, 4, 5, 6, 7, and here the values of x are negative. On this axis, values of y are positive, and on this axis, values of y are negative, right? We call this as center or origin, right? The coordinates of this origin are 0, 0. Okay? Now friends, an important thing to be observed over here is on the, this is x-axis, on the above of x-axis or on the upper side of x-axis, the values of y are positive, right? You can see over here. And on the below x-axis, value of y is negative, right? That you can see very well. Similarly, this is y-axis. On the right hand side of y-axis, x is positive, and on the left hand side of y-axis, x is negative, right? I repeat, this is y-axis, on the right hand side, the values of x are positive, and on the left hand side, the values of x are negative, right? So these are the basic things that you need to keep in your mind. Now friends, we have already discussed about independent and dependent variable. Here x is independent variable and y is dependent on x, right? So whatever values you put for x, corresponding values of y will be obtained, right? So values of x over here, we call this them as domain, right? And corresponding values of y will be part of range. Okay, domain and range, right? Here, if we discuss the graph of identity function, that is y is equal to x, we will be getting a straight line like this, right? Now, what are the properties of the straight line? See, y is equal to x. That means whatever the value of x you are assigning, the same value will be assigned to y. If x is 1, y is 1. X is 2, y is 2. X is 3, y is 3. X is positive, y is positive. X is negative, y is negative, right? So when x and y, both of them are positive, that means it is the first quadrant. And when x and y, both of them are negative, this is the third quadrant, right? So, and if x is 0, y is 0, that means this is this line is passing through origin, right? That is 0, 0. And it is in the first quadrant and third quadrant as well, because both of them are positive or both of them are negative. So that happens only in first and third quadrant, right? Now friends, the next thing is this straight line will make an angle of 45 degree with x-axis, right? Because value of y is equal to value of x, right? So suppose the basics of trigonometry must be clear. This is angle theta, this is y, this is x, right? So tan theta is y by x. So if y and x, both of them are equal, then tan theta will be 1. So in that case, theta will be 45 degree, right? So here the values of y and x are same because y is equal to x. That means this angle must be 45 degree. So this line will make angle of 45 degree with x-axis, with positive side of x-axis, right? The next thing is nature of this graph. That is, it is the graph of an odd function. That means what is an odd function? I just described. Wait a moment. So this is the graph of fx. Okay. Now fx is equal to x. So f of minus x will be what? F of minus x is minus x, right? So what is happening over here? Fx is equal to minus f of minus x, right? Fx is x, minus of f of minus x is minus of minus x, that will be x. So f of x is equal to minus f of minus x, that means it is an odd function. And if f of x is equal to f of minus x, then it is an even function. But in this case, what is happening? When x is positive, y is positive. If x is negative, like if x is minus x, then y is also minus x, right? So this is the graph of an odd function. Okay, I have explained even function over here. So you should be able to make the differentiation between the two, right? Odd function and even function. In case of odd function, f of x is equal to minus f of minus x, and in case of even function, f of x is equal to f of minus x, right? And this graph is symmetric in opposite quadrant, the opposite quadrant that you can see over here, right? So we have discussed everything about the graph of fx is equal to x, or we can say y is equal to x, right? Let's take the next graph. Now friends, next graph with us is a graph of a square function, that is fx is equal to x square. The graph of fx is equal to x square represents a parabola like this. You can say this as graph of y is equal to x square, right? So that represents a parabola that is passing through origin. Why it is passing through origin? Because when x is 0, y is 0, right? So it will be passing through origin. The next important thing is whether you put x as negative or positive, y will always be positive. Y is always positive, right? If x is 1, then y is 1. If x is minus 1, still y is 1, right? So in this first quadrant, when x is positive, y is positive. But in the second quadrant, if x is negative, still y is positive, right? So the graph will, so in that case, what would happen? We will not be able to get the negative values of y. That means the graph will lie in just first and second quadrant, because below x-axis y will be negative, but we cannot get the negative values of y because y is equal to x square. It's a square function. Okay. Now, what about domain? Domain is R, that is real number. You can have any value of x, right? Domain is what? The values of x, right? So you can have any value of x, right? So the domain of this function is R. Now, what will be the range? Range is the value that you are going to get for y, right? So whether x is positive or negative, y will always be positive, right? So you cannot get the negative values of y, right? So the range will be, so the possible answers for this function will be positive values of the number. That means all real numbers with positive values, right? Or I can say positive real numbers. So R plus. Apart from that, when x is 0, y is 0. So all real numbers as well as 0, right? So what will be the range? All real numbers as well as 0. Now, we have just discussed about even and odd function. Here, fx is equal to x square and f of minus x is equal to minus x square, that is x square, right? That means f of x is equal to f of minus x, right? So it is an even function. So you must be getting the properties of this. This is a graph that is passing through origin. Y will always be positive. Apart from that, it is an even function and it is symmetric about y-axis, right? Similar portion, that means if you fold this paper from this point, right? Suppose you draw this graph on a paper, and if you fold this paper from this line along this line, then you'll be getting both the lines are coinciding with each other, or you can say both this portion will be on one another, right? So that is called the symmetricity. So you got domain is R, that means the favorable values of X over here is real numbers, right? Whether X is positive or negative, Y will always be positive. So the range is R positive or positive real numbers. And apart from that, when X is 0, Y is 0. So 0 will always, 0 will also be a part of this range. After that, it is an even function because fx is equal to f of minus x, and it is symmetric about y-axis. We'll be discussing periodicity afterwards, right? Now, next is the graph of a cubic function. So that is y is equal to x cube, right? Now here, y is equal to x cube. That means when x is positive, y is positive. When x is negative, y is negative. And when x is 0, y is 0. That means this graph will pass through origin, right? And when x is positive, y is positive, that means this graph will be in first quadrant. And when x is negative, y is negative, that means this graph will be in third quadrant as well. So this graph will be passing through origin, and it will be in the first quadrant and third quadrant, right? Now what is domain? The favorable values of x. You can have any value of x from the set of real numbers, right? So x, the domain will be real numbers. Now when x is positive, y is positive, and when x is negative, y is negative. That means the range of this function will still be a set of real numbers, right? And then nature here, fx is equal to x cube, f of minus x is equal to minus x cube. That means f of x is equal to minus f of minus x, right? So it is an odd function. Getting my point? It is an odd function. So domain is R, range is R, it is an odd function, and it is symmetric in opposite quadrant, right? This portion is similar to this portion. I hope you are getting me. Now friends, here the next function with us is the graph is of fx is equal to 1 by x, or we can say y is equal to 1 by x. So that is xy is equal to 1, or we can say xy is equal to constant, right? Whether it is 1 or 2 or 3 or 4, maybe any number, if it is a constant, then we will be getting the graph like this only, right? Now that's an important point over here is, since x is in the denominator, x cannot be 0, right? If x is 0, this function will not be defined, right? So the basic thing over here, that x should not be equal to 0. Now if x is not equal to 0, y will never be able to 0, right? So product of x and y is equal to a constant, or we can say a non-zero constant, right? That means this curve will never pass through origin, right? Because x is not 0 and y is not 0. So this curve will not pass through origin, right? Now the next important thing over here is, since y is inversely proportional to x, we can see y is inversely proportional to x. That means if x increases, y decreases, and if x decreases, y increases, right? And the next thing is, when x is positive, y is positive. When x is negative, y is negative, right? That means this graph will lie in the first quadrant and third quadrant, right? Now suppose x is 1, so y will be 1, right? After that, if x is 2, y will be half, right? So as x increases, we can see as x increases, y decreases. The curve is coming down. Getting my point? Similarly over here, when x increases, y decreases. Okay? Now we discuss domain. Domain, as I have already told you, x cannot be 0. So we can have any value of x which is not 0. That means entire set of real numbers except 0 is the domain of the function, right? Range, if x is not 0, y cannot be 0. So all the real numbers can be obtained as the value of y except 0. So the range will be real numbers minus 0, right? Nature, here fx is equal to 1 by x and f of minus x is equal to minus 1 by x. That means f of x is equal to, so f of x is equal to minus f of minus x. That's why it is an odd function, right? Now the next graph with us is fx is equal to 1 upon x square. That means y is equal to 1 upon x square, right? Now as we have discussed earlier, if there is x in the denominator, it cannot be 0 because the function will become undefined, right? So x cannot be 0. That means y will never be 0. That means this graph will not pass through origin, that we can see from here, right? Again, y and x, both of them are in inverse variation. That means if y increases, x decreases, or if x increases, y decreases, right? So the graph will go like this, right? Here we can see as f is as x is increasing, y is decreasing, right? Apart from that, if x is negative or x is positive, y will always be positive, right? So we don't have any portion of graph below x-axis, that we can see, right? So whether x is negative or positive, right? In this quadrant x is positive, in this quadrant x is negative, but in both the cases y is positive, right? Now what is the domain of the function? Here you can put any value of x except 0, right? Whether it's a negative number or a positive number, but it cannot be 0. So domain of the function is all the numbers which are the elements of real numbers minus 0. Right? Now what will be the range? Since x is negative or positive, y will always be positive, right? So what will be the range? All positive real numbers, right? Even you cannot get 0. So range will be r plus. After that, nature, that is even or odd, just clearly we can check. F of x is equal to f of minus x, right? F of x is 1 upon x square, and f of minus x, that means instead of x, if you put minus x, still you will be getting 1 upon x square. So f of x is equal to f of minus x, that means it is an even function. Okay. Now symmetricity, this is a straight line. If you draw this graph on a paper and if you fold from the paper from this line, you'll be getting this is just coinciding with this. That means it is symmetric about y-axis. I hope you are clear. Now friends, here we have the graph of fx is equal to x raised to half, or we can say y is equal to root x, right? Now obviously x is in the square root and we are talking about the real function. That means the quantity that is, or the expression that is under the square root, that cannot be negative, right? So x has to be greater than equal to 0, right? So what will be the domain of this function? That is r plus and 0. That means all the positive real numbers inclusive of 0, right? Now if x is positive, since you are taking positive value, square root of positive value will always produce positive values, right? So y will also be real numbers, positive real numbers as well as 0, right? The next thing is nature. It's neither even nor odd because f of x is equal to root of x and f of minus x is equal to root of minus x. This function f of minus x is defined for x is less than equal to 0, right? Because x, it's negative sign over here. If x is negative, then the quantity will be positive, then only this function will be defined because it is in square root, right? So here we can say f of x is equal to f of minus x. Neither it is plus sign over there, neither it is minus sign over there, right? So it is neither even nor odd function. Okay. Now friends, here one important thing that you have to keep in your mind is the graph of y is equal to root x will be there in the first quadrant only, because we cannot take x is negative. So if x is not negative, y will not be negative, right? But if x is 0, y is 0, that means this graph is passing through origin, but that will be the part of the graph will be in the first quadrant only, right? Now a confusion arises over here is if we draw the graph of y square is equal to x, that will be different, right? It will be like this. Okay, so do not get confused between these two. Like most of the student, what they do, they square this and then draw the graph, right? But the graph of y is equal to root x is quite different from y square is equal to x. In that case, what may happen? Y may be negative, y may be positive, but x will always be positive, right? But this is not a function. This is just a relation, but not a function. Because what is happening over here? X is an independent variable and y is dependent variable, right? So suppose here we are having 4, here minus 2 and here 2. So for two elements they are having the same image, right? So this is not the scope of not in the scope of the function. Okay, so y square is equal to x and y is equal to root x. Both of them are different from each other. It is a function, but it is not a function. Okay, in this case the graph will be like this. In this case, the graph will be like this only in the first quadrant. Here you can see whether x is y is positive or negative, x will always be positive. On the right hand side of y axis, x is always positive. Okay. Now here we have a graph of fx is equal to cube root of x, or I can say y is equal to cube root of x. Now friends, here if x is 0, y is 0. That means the graph will pass through origin. Apart from that, if x is negative, y will be negative. If x is positive, y will be positive. Suppose you have to find out the cube root of minus 8, then it will be minus 2, right? And if suppose you have to find out the cube root of 8, then it will be 2, right? So if x is positive, y is positive. If x is negative, y is negative. That means the part of the graph will be there in the first quadrant as well as in the third quadrant, right? In the first quadrant, both of them are positive. In the third quadrant, both of them are negative. Okay. Domain, you can take any value of x, no restrictions because it's a cube root form. Range, so if x is positive, y is positive. If x is negative, y is negative. X is 0, y is 0. That means range is also real numbers, right? Nature of the function, fx is equal to minus f of minus x over here, right? F of minus x will be minus of cube root of x. So f of x is equal to minus f of minus x. Hence it is an odd function. Okay. So friends, in the next session we'll be taking more graphs. We'll be discussing shifting of origin as well. And we'll be discussing some basic graph of circles, parabola, etc. So do revise this session before you come for the next session. Bye-bye.